Okay, I guess the lights means that we should start. So, my name is Zvezdan Pavkovic. I'm a senior consultant in Microsoft Services, and this is going to be a Windows Azure virtual machines introduction. And I must say, you must be very dedicated Windows Azure fans. It's a 5 o'clock session. Come on, people, beers. I must make a confession. When I saw that I got the 5 p.m. session, I was like, there's going to be 5 people there. We're going to go to a pub, and I'm going to get straight scores for this session and just win the Best Speaker Award. But I guess I'll have to do the hard yards first before I get the award. So let's just dive into it so you can get to your beers by 6:30, I guess. So before we really start talking about infrastructure as a service in Windows Azure, I just wanted to touch on a bit of the history of the Windows Azure platform and how a platform evolved over time and how we ended up having infrastructure as a service in Windows Azure. So for those of you who followed Windows Azure as a platform, you probably know that it's now 5 years old. It was announced back in 2008 at PDC. And initially, the idea was we want to build this platform as a service offering to the world so that people are going to be able to really leverage the idea of the running applications in the cloud. So all the things you already heard hundreds of times, so elasticity and scalability, all those nice things that cloud should bring to the table. But from the get-go, we got the feedback from our customers that said, oh, we want to do this, can you add this feature, or can we expand and be able to do this? So back in 2008, initially well, I shouldn't say all that you could do, but only code that you were able to run on top of Azure was essentially .NET. And then over the years, we rolled out stuff, so you're able now to run native code, you're able to run PHP, Java, etc. I mean, the list is just too long, and I don't really remember the whole list anyway. So, but over the time, we added features on top of the features and expanded the capabilities of the PaaS platform to what it's today. And then over time, also, people came back and said, but why can't we run a virtual machine up there? I mean, it's a cloud. We should be able to run a virtual machine. So a year and a little bit ago, back in June 2012, Windows preview for Azure virtual machines essentially was made available, and this offering hit the general availability back in April this year. So what I want to touch on this slide is actually to go to what's actually the differences and why we need to have infrastructure as a service also in the cloud. So one of the first big differences is about the storage. If you ever use Windows Azure as a platform, then you know that essentially both the web role and the worker role are essentially stateless. So if you, for whatever reason, web role or worker role is restarted or moved between the host, you lose whatever you had in the memory. So it's completely stateless. So you need to write stuff somewhere, either into a Windows Azure storage or use a SQL database or whatever you wanted to do with that data. On the other hand, if you want to run a VM, you want to have a persistent storage. You want to write data to the drive, and then later on, being able to read the data back. And also, with infrastructure as a service, you would potentially want to add storage and be able to manage the storage around. The second big difference between the PaaS and IaaS is that networking was done completely different in PaaS. So to be able to resolve the names between the VMs, the web roles or worker roles in PaaS world, you would have to essentially call the API and figure out which machine is which and then do whatever you need to do. While in IaaS world, you would potentially want to be able to use a DNS name service, so to resolve the names and being able to connect. Thirdly, in terms of deployment, in PaaS world, you essentially get the stock VHDs, and that's what you're going to run in the cloud. In IaaS world, you would like to be able to have custom images or custom VMs, upload stuff to the cloud and attach that to a VHD, that kind of thing. And lastly, the primary use. The primary use of PaaS is you want to build a stateless application that's going to be able to fully leverage the capabilities or what's provided by the cloud. So essentially being able to scale out elasticity and high availability that's provided by the platform itself. In IaaS world, you essentially want to run a VM and potentially move some stuff that you have on-premise, or you want to extend your on-premise to be able to run the VMs on the cloud platform. So taking this all in account, when the decision was made to essentially develop IaaS and make virtual machines available on Windows Azure, these are sort of like guiding principles that we wanted to achieve from that offering to the market. So first of all, it has to be IT pro-oriented. And when I say that, I mean when you look at the PaaS, it's all about the developer. So you need to have your Visual Studio, you need to understand how the platform works underneath, et cetera, et cetera. So what we wanted to achieve with IaaS is that the IT pro who is managing a Hyper-V farm or managing a VMware farm or whatnot is able to jump in and say, okay, I understand this, I can just jump in and start using it. So that was first goal. The second goal is we need to be able to support key server applications. And when I say key server application, I mean SQLs and your System Center suite, so that you're able to actually move your on-premise loads and move them to the cloud and run it up there. Thirdly, storage. So we needed to be able to easily provide storage management, so it's relatively easy. So it's easy to add storage or remove storage from the VM. Fourth point, high availability. I mean, what's the point of running the whole thing up in the cloud or on somebody else's host if you can't get any kind of high availability? So the fourth point was there has to be easy configurable options to achieve high availability in Windows Azure. Fifth point, advanced networking. It ties back to the limitations or the idea how the PaaS was supposed to work, and it ties back into the idea that now you have to be able to actually achieve the networking not only between the VMs that you're potentially running in Windows Azure, but also allow for the networking between the VMs that you're running in the cloud with your on-premise infrastructure, and also allow you to network between your application that you're running on PaaS with your VMs that are running as an infrastructure as a service. And finally, the last point there is to be able to actually integrate between your VMs with the compute part of the PaaS. So before we dive further, because I don't want this to look like a marketing presentation, I'm going to jump straight into a console and just show you how easy it is to provision a VM. So do you notice the left corner start button and the menu? So you click on a new and compute, virtual machine, and then we're just going to go quick create, and we just need a name. So I assume that you all think we can provision a Windows machine. So I'm not going to provision a Windows machine, I'm going to provision a Linux machine just to show that we are equal opportunity cloud. So okay, so the DNS name is valid, not used. And I'm going to say just Zoo and password. There is an interesting thing about the passwords in Windows Azure that it's not only that you need to meet the complexity, it's also that we are double-checking the known passwords that used in the wild. So as you probably know, in the last few years, there were a lot of hacking attacks that essentially got to the hashes of the password. So all those passwords are essentially invalid now. So if you try to use, capital P at SSWRD1, that's not going to work. So you really need to come up with a password that's relatively complex. And the last thing that you just need to select is essentially in which data center you want to create this, and that's it. So while that's happening in the back, I'll jump back to the presentation. So as you can see, I'm provisioning a VM in like 60 seconds. It took me 60 seconds to provision a VM. And it's going to take actually another maybe 2.5, 3 minutes for VM to be provisioned. So my configuration part was like 60 seconds and another 2.5 minutes for VM to be actually provisioned. So let me just quickly jump back to the PowerPoint. So I was moving a bit fast to that UI. Let me just, so I don't know if you noticed, but there is a bunch of pre-staged images in the library. And those images, of course, include the usual suspects. So you have your Windows Server 2008 and Windows Server 2012, and also a number of server applications, like BizTalk, SQL, etc. And not only those, but also we have supported Linux images if you're into it, so you can run a Linux on top of Azure. And just to show the number of available images, cloud, come on. So as you can imagine, that's a long list. So to make it a bit more measurable, so that's 111. So there is 111 images currently pre-staged in the library that you can access at any point in time. So not only, we have our usual suspects in terms of the operating system. There is just a small, let me just jump to the next slide. This is essentially sort of the list of the server applications that are supported out of the box, or not only supported out of the box, but available at this point in time on Windows Azure. And just to give you a bit of warning in regards of arguing about the supported applications, I'm going to jump to, this is, if I manage to find my mouse. This is, this one. This is a list of supported applications on TechNet at the moment. So the important bit that I want to point out is not the list of the applications, but actually get to this bit here. So the last update was 6 days ago. So the thing is, the point I'm trying to make is, before you start arguing what's supported and non-supported, check this page, because these guys are releasing stuff on a weekly basis. So if something was unsupported or not supported, a couple of weeks back, it could actually get on the list in few weeks or few months. So this is a really important page for you guys to make sure that you have the latest information in terms of what's supported and not supported on the platform. Okay. So not only that, but I can also additionally show you this bit. So if you're looking for, let's say if we are looking for a specific image type, I can easily do something like this, and this is essentially going to list me all the images of the R2 preview that are currently available. And then being able to do something like this allows you to fully automate the provisioning of the VMs to PowerShell if that's your thing, if you don't like the UI or you need to provision something complex. Or something that makes maybe more sense if you are a SQL person and you want to provision a bit more than just a base OS. So this is going to list all the SQL Server images. And as you're going to see here, there is a bit more than for the OS, but the important bit, you then end up with having an options to, I don't know, look for, if you need a specific version, so you need a SQL Server 2012 SP1 on top of the Server 2008, or you would rather go and do, just jump top the list, it's a long list, or you would rather do SQL Server 2012 on top of the Windows Server 2012. So those options are available if you are looking for a specific operating system. And now you could do a similar thing for BStalk or SharePoint or whatnot, whatever you're looking for. Okay, let me just jump back. So that's supported server applications. And just one slide on Linux. So we fully support the above application, and we work with their providers to make them supported on the Azure platform. So as I said, the specific versions on the slide are the ones which are supported. But you could essentially take any recent version of Linux as long as your kernel has the Hyper-V integrations components in there, which was now for 2 years back. So you shouldn't have any problems running Linux on top of the Windows Azure. Okay. Now that we've come through the versions of the operating systems and server applications that are supported, we can jump in and talk about where we're actually storing this data and how this data is stored, and how the image and the disk subsystems are handled in Azure. So the first important thing is that you do have to take a bit more care about the storage subsystem of your VMs compared to when you're running on top of your own Hyper-V or VMware infrastructure on-premise. So the first thing is that we have this divide between what's called the OS disk, operating system disk, and then a data disk. And these are essentially the capabilities and differences between those two types of disks. So, the OS disk can be bigger than 127, and data disk can be 1 terabyte, et cetera, et cetera. But the really important bit is the last row, where it's all about the cache settings. And so the OS disk is always either read-only cache or read-write cached. So when you want to store data in a VM in Windows Azure, you want to set up your data disk. So if anybody of you tried or looked at the instructions for hosting Active Directory domain controllers in Windows Azure, it clearly states somewhere at the top of the document, provision a data disk, set a data disk to no caching, and go for that and use that disk for your data. Because this is a platform where your VM at any point in time can be moved, restarted between the hosts. So you want to make sure that the data is written back to the drive that the VM is using for storing data. So your Active Directory database or your SQL database, provision a data disk, and set caching to none so that you make sure that the data is written back to a drive. And just to show how easy it is to provision additional storage, just jump back. This all can be done to the UI. I just love PowerShell. So I already have the VM called W2K12R2 TechEd, and I already provisioned one data disk to it. And it's going to just take me a single command oops. Just going to take me a single command to provision additional 1 terabyte of storage to that VM. So I'm going to, sorry. Just a sec to fix this command. So while that's churning along, that's going to take maybe a minute or two. I'm going to actually remote into that VM. Okay. So this is the one. Come on. Okay, this is still provisioning. So I just want to show you how easily you can get loads of storage into the VM. I already provisioned, if we go back to there, I already provisioned 1 terabyte drive there. So if we go to the VM here and dashboard. So you can see I already provisioned before we started. I provisioned a 1 terabyte drive there, and hopefully, okay, that succeeded. So so that took like 90 seconds. So there is my second drive, and just bring the RDP session over there. So that's my server. And I want my disk management. And there is two 1 terabyte drives. And I can strip them, format them, do whatever I want. So if you have a huge database, or you need a huge amount of storage, you will be more than able to do that in Windows Azure. Because you can actually, let me just show you that, you can have, so these are the sizes, and this is the biggest size. So the A7 and 16 there stands for 16 data drives. So you can have a raw 16 terabyte storage capacity attached to the VM. So if that's not sufficient, then you probably should think about running it on-prem. But other than that, this is like, I would say, 99% of your data requirements would be served by A7 type of the virtual machine. And I just wanted to just go there. So there, two 1 terabyte drives in few minutes. Just close that. Okay, back to the deck. So as I said, OS disk is essentially, can always have some sort of cache enabled. It's either both read-write or read-only cache, and then the data disk can be any of three, so it can be none, read-only, and read-write. Typically, you would attach the data drive, set the caching to none to make sure that you maintain the data integrity on that drive and use it in such a way. And of course, there is a PowerShell command that will allow you to do that from the command line, or you can do that from the UI. So it's all great that you can provision 1 terabyte drive, but where is it actually, how many times and how highly durable or persistent this data that we are writing in Windows storage is? So to explain, when you write data to a drive, it essentially gets written down 3 times within one data center. And then if the geo-replication is enabled, it's then going to replicate it to a secondary data center in your region, and essentially you end up with having 6 copies of data. So I would say that's highly durable. And then, of course, if you lose the particular virtual machine, we spin up another machine, it just connects to the same storage. Okay, so now that we've covered that the data is written 6 times and that it's highly improbable that you're going to lose that data up there, I just want to touch on some other important bits and pieces about the storage and how the storage is sorted out and what you can actually do in terms of storage and image mobility in Windows Azure. So first of all, as I said, we have OS image disks, and these base OS images are prepared by Microsoft, and they're sitting in a library, are essentially, run-of-the-mill vanilla images of 2008, 2012, and other operating systems. What you can do is, let's say you have a VM that you're running on-prem, and you have the VHD of that VM. You can quite easily, shut down that VM, upload the VHD to the Windows Azure, create the VM there, and attach the drive, and it will just work. And that this works the other way around. So you can as easily download that VHD back if you want to run it back on-prem, and just run that, bring it back down, create a VM, attach the VHD, and have the mobility between your on-premises and the Windows Azure cloud. The other option that you can do is essentially, if you have the usual golden image or Windows Server SOE or whatever you call it, and you want to use that image to provision the VMs, you can as easily upload that VHD, and it will end up in a library. And as I was creating the VM at the start, you simply go to the creation wizard, you specify image you just uploaded as a base image, and it will be and your VM will be provisioned from your golden or SO image for the server, like this. And the last option is you can do all this, or you can have your custom image even without having your on-premise infrastructure. And what that means is that you can actually create the VM in a cloud, add bits and pieces of software that you want to have within your SO image, and then essentially capture it within the Windows Azure environment, put it in a library, and then reuse it to provision. So boot VM, customize, generalize, capture, and then use that image to provision new servers. So just few tips on generalizing the image. So it's the usual process. So you install your operating system, you add bits and pieces of the software that you want to have within the VM, and then you sysprep and generalize. I would say the two important things that you need to keep in mind: the VHD has to be fixed size. So you can't create this in an auto-expanding VHD. And the other thing is, do not put unattended XML within the image, because the things that we do when we provide information in a UI or in a PowerShell commandlet to provision the VM, information that you provided there, so your admin passwords and stuff like that, or VM name, are actually then picked up on the fly and injected into the VM as an unattended XML. So if you put the unattended XML, then we can't inject our unattended XML to provision this virtual machine properly. And also, there is no need to install what's in a password, where Windows Azure Integration Component or Windows Azure Agent. So apart from these two important bits, you need to go with a fixed VHD and no unattended XML in the image. It's pretty much the same process that you're probably using every day on-premise. Okay. So the next bit is, it's all fine. We have our OS images. We can create the VM, but where is this VM actually running? So back when Windows Azure was released and as a PaaS platform, they introduced the concept of what's called the cloud service. And the cloud service was essentially a management, networking, security, etc. boundary for a certain number of either web roles or worker roles. And the similar concept of a container that's needed to be provisioned with VM to keep them together in a logical enclosure was used for the virtual machines for the IaaS, for the infrastructure as a service, and for hosting virtual machines. And when I say it's a boundary, I think the best way to explain this is actually give you an example. So if we go back to the console here, you can see cloud service. You can see that I have 3 cloud services defined here. And so this is one, and if I click there, and you can see that I have my instances there. So this is 2 Windows Server 2012 servers. Over here, I have only 1. But the important bit in terms of boundaries is this. If you look here carefully, deployment name, where is my DNS name? Just a sec. There. So you can see that the DNS name for these two VMs is actually the same. Can you see that? There. And then this one VM has this name and this one has this name. So the cloud service container defines a boundary for the VMs within that container and how they're seen from the external world. Not only how they're seen from the external and the above DNS is essentially how you can access them from the internet, but also define the internal networking boundary for the VMs that are within the same cloud service. And I will explain later on what I mean by that about the networking. And now, just moving further, I want to touch on the next topic, and that's the notion that the virtual machines, that we should provide a high availability for the virtual machine that we are running on top of Windows Azure. And our service level agreement specifies that we can provide you a 99.95% availability for multiple role instances. And this is something that actually needs a bit more explanation. So what do we mean by multiple role instances? We mean the following. We mean that you have to have two servers doing the same thing, and we can guarantee that at least one of those instances is going to be up. The service level agreement includes any computer failure, any computer hardware failure, so this CPU, memory, networking, whatnot, or the data center failure. So we can guarantee that at least one of the VMs is going to be up. And later on, I'll give you some examples how you can actually craft a highly available solution using this. What's not included in our service level agreement is whatever you do within the guest OS. So whatever happens within your VM. So we only guarantee that the VM is going to be up. So you're still responsible for the software that you're installing inside, for the guest OS updates, et cetera, et cetera. And to be able to achieve this, we introduced two concepts. One is what we call a fault domain. And fault domain in data center represents essentially a group of resources that you, when you're designing a data center, anticipate is going to fail together. And in case of how we are building a data center, that means that we expect a whole rack to fail. So we expect that when we are putting VMs on different hosts, that we cannot put two VMs that need to be highly available on same rack. So we need to put them on different racks. So that's one concept, and the other concept is the update domain. The update domain is essentially a set of servers in a data center that will be updated together. Because, as you probably know, Windows Azure essentially runs on top of Windows Server 2012 now. So every first Tuesday, we are patching, as everybody else, I guess. So we also have to have this update domain concept that allows us to position the VMs in such a way that we never take all the VMs in a same availability set. And just, I think this is going to, so this is how this is done in pairs. You have your web role, you have your worker role, fault domain, and then each of the instances is in their update domain. Similarly, with virtual machines, let's say I have 2 web servers. I define an availability set for them. They're then set on 2 different racks, and then they are also positioned within the data center, placed within the data center on the hosts that don't belong to the same update domains. And I do have a quick demo to show you how this is easily done. So if we jump so I have 2, as you've probably seen, I have 2 VMs, IaaS VM1 and 2. And this bit of PowerShell there is going to go out and essentially create, sorry, wrong demo. I'm going to do this to the UI. So what I can do is jump in here. And I already created an availability set there. And just notice, so at the moment, the only VM that's part of this availability set is IaaS VM1. I jump over there, and then just click Save. And when I finish this, when the configuration is finished, essentially these 2 VMs will never be part of the same fault or update domain. Thus, if we have a host failure or a whole rack failure in a data center and you lose 1 VM, the other one will be placed on some other rack, so it won't be affected. And the same thing when we're going in and updating the hosts, we will never update both hosts that are running those 2 VMs at the same time, thus making sure that at least one of the VMs is up. Okay. And now just to explain, so how can you actually build a highly available solution using the availability sets? And this is the simplest example. So let's say you need a backend, you need a SQL server at the backend for the database. So you can essentially create availability set for 2 SQL boxes and then either set up a SQL mirroring or go with the SQL always on solution. And then create the 2 boxes that would run, let's say, IaaS web application front end, and load balance that front end, and then essentially the whole solution is highly available. I'll go into it, how the load balancing is done in few slides. So I think this is the last one. The point that was made that we need to do well for the infrastructure as a service is that we needed to redo how the networking is done. So with IaaS, what we bought and what was one of the big points were control over the virtual machine names and also the name resolution. And not only that, it's not only that now you can have the full control over the machine's names, you can also, we now essentially provide a DNS service for your VMs. So as you remember, I mentioned that the cloud service is a boundary. So for instance, when you're provisioning the VMs and you provision a number of VMs within the cloud service, essentially those VMs share a DNS or a DNS service, allowing them to resolve each other's names while they can't go outside that bubble that's provided by the cloud service. And also with the DNS, we also now allowing essentially to either extend your DNS infrastructure from the on-premise to the cloud, or even build completely new DNS infrastructure within the cloud. And I'll go in further details regarding that. In terms of protocols and endpoints, UDP is now fully supported both for incoming and outbound traffic, which allows you to do the streaming services, all IP-based protocols between the VMs, port-forwarded endpoints, and custom load balancer probes. And I'll go and explain what both port forwarding means and load balancing help probes. So just to jump quickly and explain port forwarding, and it ties again back into how the cloud service acts as a container. So if we look at any VM that we've provisioned so far, and we look at the endpoints. So let me just go back here. So as I said, each VM we provisioned has to become a part of the cloud service. And the cloud service essentially, one of the tasks is to provide a publicly resolvable DNS name. So our ISVM1 is part of this cloud service. And as you have seen, I managed to RDP into a VM. So I resolved this name. But then to actually get into the VM, I've hit this endpoint. So I have an endpoint that has a public port on a cloud service, and then that port is essentially mapped to a 3389 for RDP, allowing me to essentially publish any internal port of the VM to the externally resolvable cloud service DNS name, as it's shown here. So I can have my cloud service, number of VMs, and then I can have my ports, public ports, allowing me to hit the RDP port on the VM within the cloud service. Similarly, we can do something like this. So when you want to actually be able to load balance an application, and as an example that I showed a few slides previously where you have an IIS front end, you can then tie up a number of VMs and essentially load balance them. And I'll just quickly jump into PowerShell to show you. So the thing is, we need to create something that's called, we need to create a load balancer. So let me just, there. This was the example I was showing. So a quick PowerShell. So what we're going to do, we're going to pick up a service name, TechEd 2013. We're going to get the VM, and then we're going to add the endpoint there. And hopefully that's going to happen quite quickly. And while that's running, so I'm going to create this endpoint and essentially mark this endpoint that I want to use this endpoint as a load balancer. And then I'm going to jump into the UI. And do an F5. And there is my endpoint. So HTTP port 80, private port, and it says it's load balance. So this is my first IIS box. I jump to my second IIS box. There is no port there. And I'll do this to the UI just to make it different. So add, and then I can go and say add endpoint to an existing load balance set. So this is my, that I just created. Click Next. Wait a few seconds. And while that's happening, let me just show you something else. So notice that I have the HTTP that I just created, which hits port 80 and then private port 80. But I also have this other bit here. So I can hit the port 30,000 and end up on the private port 80. So over here, so I'm hitting cloud service IP, FQDN, hitting port 30,000, and then if I have F5, that's my VM1. Are we done with this? Come on. Maybe it's done. So what I'm going to do now, I'm just going to lose the port here. So I'm going to hit D80. And then F5. Gods of demo. We done? Come on. Just try maybe it's cache the graphics. Ah, there. So obviously this is my design choice. So I'm now essentially hitting either one or the other VM in the load balance set. And again, it took me like, what, 2 minutes to set up the load balance set between two VMs. And lastly, there is a load balancer probe that runs anyway at the background, which allows you to essentially shut down the VM. So it's not a simple round robin. So the normal probe just hits the port that's defined in a load balance set and expects to get HTTP 200, but you can also go and set up your custom probes. So you can say, okay, don't just try to get the HTTP response. Can you actually go and run a piece of code that's going to return HTTP 200 to make sure that the application is actually working? And moving forward, so that's about the load balance sets. I'm just going to dive into DNS and name resolution. So we essentially have 3 scenarios. First scenario is what I already explained a little bit. So you provision your VM within the cloud service. You provision a number of them. And essentially, the cloud service acts as a container. And the DNS and the VMs provisioned within the cloud service have their own small bubble, and the DNS service provided just for them. The other option is, and I'll come back to how you establish the VPN and how you can do this. The other option is essentially you connect your Azure-based VMs to your on-premise infrastructure. You supply the details of the DNS service that you're running on-premise and essentially use that DNS to allow the VMs running in Windows Azure to resolve names. You can even connect your on-premise and Azure infrastructure in such a way that you actually have a domain join, domain controller running on top of the Azure so that it's close to the VMs. And the third option, or 3.A and 3.B, you can actually set up the whole DNS infrastructure within the which is not provided by Windows Azure, but actually, for instance, installing a fully functional domain controller, DNS running on that domain controller, and then joining VMs to that domain and using that domain's DNS servers to resolve names. And as I said, there is a 3A and 3B. And also, there is a variant of the last where you actually don't even have a DNS service in your cloud. You can actually point your VMs to a publicly available DNS service if you want to. So I can control the DNS settings for the VMs running on top of Windows Azure. And lastly, probably the most important thing, and the thing that actually allows what I was just explaining about the DNS, is what we brought and which is essentially called virtual networks, and what allows not only being able to have those DNS scenarios, but also allows and cross-premise connectivity between your on-premise servers and VMs running in Windows Azure. So in terms of cloud-premise connectivity, top two rows are essentially what already existed with the PaaS. And what we brought with the IaaS is these two bottom scenarios. One is essentially secure machine connection to the Windows Azure. And that's mostly used to connect the single client to the Windows Azure, allowing for dev test scenarios where you want to have your, let's say, dev machine connected to the VPN directly to the Windows Azure machines. And the second scenario that I'll talk a little bit more is actually being able to establish a VPN tunnel between your on-premise infrastructure and the Windows Azure. So before I explain what the virtual network actually is, I just want to touch on a few points. When do you actually need a virtual network? So first of all is IP address requirements. You want to use a certain subnet. You want to almost have close to static IP address, where essentially what you do when you provide the virtual network to the VM, you provide them with the IP address with the infinite lease. And not only that, but you also can control which DNS service the particular VMs connected to that virtual network are actually using. If you want to establish a hybrid on-premise cloud applications, so essentially if you want to establish a VPN tunnel between the on-prem and the Azure cloud, you have to have a virtual network. And also, if you want to be able to connect different cloud services between each other. Okay. So let me just jump straight into how this helps you with cloud services and connecting them to each other. So the cloud services that I showed you so far were essentially provisioned without the virtual networks. And the virtual networks is essentially an overlay on top of the cloud service, allowing you to essentially share the network between those two cloud services. Let me just jump back to and show you what I mean. So these three are essentially just cloud services without the virtual network. So I get the IP addresses that Windows Azure provides me at any point in time. If I actually wanted to connect them together so that I'm able to communicate between, let's say, my IaaS servers and my Linux server, I would have to first create a virtual network and then create the cloud service and the VM within the cloud service. Then, as the VMs are sharing the same virtual network, I can have something I can have something like this. So I can have my load balancer in front, and then I can have one cloud service, and then another cloud service, and they will be connected to the VNet between those two cloud services. Similarly, when we talk about the VPN tunnel between the on-prem and the Windows Azure, you can have your essentially VPN tunnel hitting your VNet created for those three services on the left, and then allowing them to either your clients coming from the corpnet going inside, or even having the external clients hitting the load-balanced IS server, for instance. And then just in a summary, so what the virtual network actually provides you is that you can actually bring your own IPv4 addresses. So if you want to continue to use a certain set of subnets, you can use that. Controls, but what's more important, it controls the placement of the Windows virtual machines on Azure, and allows you to both either to connect the VMs within the cloud services. Not only allows you to connect the VMs within different cloud services, but what it also allows you is that you can actually have, let's say, a web role running as a PaaS, and then connect that PaaS cloud service to infrastructure as a service backend that's running your SQL servers. So the VNets allows you the connection between the PaaS world and the infrastructure as a service world in Windows Azure. Furthermore, it allows the site-to-site connectivity and the DNS, all the features for the name resolution that I mentioned before. And by this summary, I'm finishing up. I guess some of you already been to ILL, and these are all other related sessions for Windows Azure virtual machines. I think I need to tell you that if you fill out your session evaluation, you're going to get a scalp mouse if you get drawn. And that's it. Thank you so much. Question and answers. No questions.
With the network load balancing.
Yep.
With Windows network load balancing, you can set up single infinity
Okay.
so that the client can actually come back to the same server. Can you do that, or is it always round robin?
It's not round robin, as I said. So there is a probe that checks if the server is up. What you're talking about is session affinity. Will it keep the session if the server is up? Answer is yes. It will keep the session. The client will keep the session. Yeah.